All right, I'm looking at the Algebra 1, Chapter 2 practice test for Mrs. Wheelock's class. We're going to be talking about solving, graphing, all kinds of different inequalities. Now, inequalities are different from equal sign. We have greater than, we have greater than. Those little lines mean the same thing, or equal. I forgot to put the line underneath. We have less than, and less than or equal to. Please forgive my writing. My good stylus broke. And so when we're going to graph, this is G is greater than 1. So we draw a number line. I always like to put 0 on it. It's always nice to kind of have that reference. And there's 1. Then we have 2, 3, -1, -2. It's not necessary to put all the numbers on the number line. And greater than, without the or equal to, is an open circle. So we use an open circle on the 1. Let me do this in a different color. Open circle on the 1. And the numbers that are larger than, greater than 1 are 2, 3, 4, and all the fractions and decimals in between. So the shading is to the right. These are the numbers that are greater than 1. Now, Z, number 2, it says Z is less than 12.5. Okay, and I'm not going to put all the numbers in between because it's getting pretty large there. But less than with not the equal to, again, is an open circle. And we're going to graph all of our answers on this, so there's going to be lots of practice to show you how to graph these on the number line. Is less than 0 is less than 12.5, and all the numbers on this side are less than 12.5. Now, solving an inequality is very similar to solving an equation. The main difference is if we divide or multiply by a negative, we have to flip the inequality. The key term here is by a negative. Okay, because we can multiply a negative by a positive and it doesn't change. The sign flips. So if it's less than, it goes to greater than. If it's greater than, it goes to less than. So here we are, number 3. T minus 9 is less than -6. So I solve this just like an equation. The inequality sign is like my equal sign. I'm going to get t by itself, so I need to add 9 to both sides. And the 9's zero out on this side, and you're left with t. I didn't divide or multiply, so my sign stays the same. And -6 plus 9, bigger number is positive, so the answer is positive. Subtract them. 9 minus 6 is 3. So we'll draw this on a number line, just like we did the first 2 problems. We'll put our 0 and our 3 on here. I don't know why I do it like that. 3. It's just less than. Doesn't have the line underneath, so it's not equal to. So it's open circle. When it has a line underneath, it'll be a closed circle. And 0 is less than 3, so we're going to shade towards the 0. It's really important that you know what the symbols mean. If you're not shading it correctly, you're going to miss quite a bit of points on the test. So make sure you know what the symbols mean and ask yourself which numbers are less than or greater than the ones I'm trying to shade. Don't just shade in the direction of the way the inequality points. Number 4 is n minus -4 less than or equal to 23. Now this minus a negative becomes plus positive, so I'm actually going to subtract 4 from both sides. And there's my little line. So n is less than or equal to 19. We'll draw our number line, 0, 19, and we have a closed circle for less than or equal to, and less than 0 is less than 19, so we're going to shade towards the 0. So it's kind of a good idea to put 0 on there, and you can say, is 0 less than, is 0 greater than, and you'll shade towards it if your answer is yes, and you'll shade away from it if your answer is no. Number 5. It is, I'm going to write it here and then I'll move it up. 6 minus 5 plus n greater than or equal to 18. Now here I want to combine like terms first. My like terms are the 6 minus 5, which is 1 plus n greater than or equal to 18. Here's my line that I'm going to work on. Make sure I do everything on both sides of that line. Subtract my 1. N is greater than or equal to 17. And there's 0, 17. Is 17 greater than 0? No, 17 is not greater than 0. So the shading is on the other side, the opposite side that the 0 is on. And close circle because it is greater than or equal to. Okay, so let's look at number 6. 13 minus n plus 2n is greater than 8 plus 1. So let's look for some like terms because it looks like I have more than one variable. I have negative n plus 2n, and I have 8 plus 1. So we have 13 plus n is greater than 9. 8 plus 1 is 9. Negative n plus 2n is positive n. And then it's our little line that we're going to do everything on the other side of. So 13 minus the 13 to get n by itself on this side, minus the 13. So n is greater than, bigger number is negative, so the answer is negative. 13 minus 9 is 4. And we'll draw a number line, 0, negative 4. And we'll do an open circle because it's greater than, not greater than or equal to. And 0 is greater than negative 4, so we'll shade towards the 0. Number 7. 6k is less than or equal to 30. So that's 6 times k. The opposite operation there is divide, so we'll divide by 6. And I'm dividing by the positive 6, so my sign's going to stay the same. K less than or equal to 5. Number line, 0 and 5 on there. Close circle. And 0 is less than 5, so we'll shade towards the 0. Number 8. 6 is less than or equal to b. Oops, that looks a lot like a 6. Let me fix that. Let's do a capital B. Divided by 10. Now that's divide. Okay, we get caught up and we think, oh, it's a fraction, I don't know what to do. But this is division, and all you have to do is undo the division. So multiply by 10. Multiply the 6 by the 10. And we get 60 is less than or equal to b. Which means, if we flip it, I like my variable first, so I can shade it better. So 60 is less than or equal to b, which means b is greater than or equal to 60. And then I can draw that on the number line. 0, 60, and closed circle, greater than 60. 0 is definitely not greater than 60, so we're going to shade the opposite direction that the 0 is in. And number 9, negative 2 less than k over negative 2. And again, remember that that is division. And so the opposite of divide is multiply by negative 2. Multiply by negative 2. Now, I just said multiply by negative. That means the sign has to change when I do the next step. So negative 2 times negative 2 is positive 4. And then 2's and negative 2 cancels, and we have k is less than 4. So when you flip it around, the numbers should be on the same side of like the inequality symbol. Like the point is near the K on this one. The point is near the K, and the opening is by the 4, so when I flip it around, the point should be by the K, and the opening should be by the 4. And we can draw that on a number line. Less than 4, open circle, because it's just less than. And 0 is less than 4, so I'm going to shade towards 0. Okay, number 10. Negative 8z less than or equal to negative 24. That's multiplication, so we're going to divide by the negative 8. And the number that I'm dividing by is negative, so my sign is going to change to greater than or equal to. The 8's divide out, and z is greater than or equal to 3. I'm going to draw that on a number line. I have closed circle at the 3, and 0 is not greater than 3, so I'm going to shade the opposite direction of the 0. And that's my number line. Number 11, 2 minus m over 11 is less than or equal to negative 7. Now this type of problem messes us up frequently. Okay, that negative, this negative here, is with the negative m. Okay, so the negative is with the m, and the 2 is out here actually being positive. And so to move it to the other side, I need to subtract 2. Okay, I didn't divide or multiply, I'm just subtracting. So that zeroes out. I get negative m over 11 less than or equal to negative 9. And now I want to get rid of that negative and that 11 at the same time. So I'm going to multiply by negative 11. And I'm multiplying negative 9 by negative 11, and that is why my sign is going to change. M is greater than or equal to 99. And this is one of the reasons why I don't fill lots of numbers on my number line. And it's okay, on the test it has little dash marks. You don't have to put 0 on there. It doesn't have to be equally spaced. You don't have to put every number on there. Just make sure your main number is on it. And then it's shaded correctly. So we have greater than or equal to, which is a closed circle. And 0 is definitely not greater than 99, so we're going to shade the opposite way to the right. Number 12. 12b plus 12 is greater than or equal to 60. And we're going to move the 12, this 12 that's being added. So we have 12b greater than or equal to 48. Divide by 12. B is greater than or equal to 4. And draw that number line. Close circles because it's greater than or equal to. 0 is not greater than 4, so we're going to shade to the right. And number 13, we have 3 plus p over negative 3 less than or equal to 8. And I'm going to see if I can move this problem out of the way. Let me just erase that and move it so it's not in the way. I'm going to move this stuff up out of the way. And we'll do 13. 3 plus p divided by negative 3 less than or equal to 8. If you read the problem in your mind too, it kind of helps you understand like what operations you're doing. 3 plus p divided by negative 3. Now you realize, oh, I'm going to multiply. Just little things like that. Again, this is one of those backwards ones, the p over negative 3 here, and this 3 is positive, so we're going to subtract it, and we get p over negative 3 less than or equal to 5. And I want to get rid of the negative 3, so multiply by negative 3, multiplying by a negative 3. And so p, the sign has to flip, greater than or equal to negative 15. And draw that on the number line. have closed circle, greater than. Okay, and then number 14. 35 less than 5 times r plus 4. So on this one, we're going to distribute my 5. When you have the parentheses in front of the number in front of the parentheses, remember that this means you're multiplying. So I can distribute 5r plus 20, 5 times 4. And then we'll solve the problem like usual. Minus the 20. So 15 less than 5r divided by the 5. And 3 is less than r, which means r is greater than 3. Remember what I said about keeping it in the same orientation. It's open to the r, it has to stay open to the r. And then I would like to graph it from there. And 0 greater than, close circle. 0 is not greater than, so we're going to shade to the right. All right, number 15, we're going to look for some like terms. Every time you see more than one x, more than one number on the same side of our inequality, we're looking at like terms, and we just combine them the way it says. So 18 minus 8x is just 10x plus the 4. And then our other like terms on this side are 13 plus 21 is 34. And it's still greater than. We're going to subtract our 4 from both sides. We get 10x is greater than 30. 10x means 10 times x, so we're going to do division, the opposite, the inverse operation, and x is greater than 3. We'll draw that number line over here. 0, 3, open circle because it's greater than, just not greater than or equal to, and 4, 5, and 6, that's where these numbers are, where I'm shading, and those are greater than 3. Number 16. This is a compound inequality. This is an and, to negative 2, greater than negative 5x minus 2, greater than or equal to negative 17. I don't know what it's doing. We treat this like we have 2 lines. We're going to do whatever we do on this side, whatever we do in the middle, whatever we do in the middle here, we're going to do to the right and to the left. Okay, we're going to treat it as one big equation. So I'm going to add 2, and add 2. And then I get 0, negative 2 plus 2 is 0, is greater than negative 5x, is greater than or equal to negative 15. And then I'm going to divide by a negative 5. And since I'm dividing by a negative, my sign's going to change. I get 0 less than x less than 3. So what this means is we have numbers between 0 and 3, and it includes 3. So 0, 3. 3 is going to have a closed circle, and the 0 is going to have an open circle. And as we read this, x is less than 3. That is shading in here. And it has to be also, x has to be greater than 0. So that is these numbers here. So when we shade, we're only shading the in between these two numbers right now because these are the numbers that are both less than 0 and less than 3, greater than 0 and less than 3 at the same time. Number 17, 10 less than x plus 5 less than 14. So again, I have my 2 lines. Whatever I do to the inside, I'm going to do to the right and the left. So we're going to subtract 5. And we get 5 less than x less than 9. We have 5 and 9 on here. We have two open circles because they're both less than. And less than 9 and greater than 5 is everything in between here, so we're going to shade that. Let's do it with a highlighter. Okay. And then number 18, let's just move this stuff out of the way. I'm going to move it over here so I have room. -4 less than or equal to 1/2 times the quantity of 8x plus 8 is less than 12. So here are my lines. I'm going to distribute my 1/2. Okay, 1/2 times 8x is 4x. 1/2 times 8 is plus 4. Less than or equal to on this side. Then we're going to subtract 4. Well, this 12 comes down and this 4 comes down. -4 and minus, it's already -4. So then we have that -8 is less than or equal to 4x less than or equal to 8. And then we'll divide by 4. Divide to the right, divide to the left. And we get -2 less than or equal to x less than or equal to 2. And on a number line, 2 and -2, we're closed circles for both of them. And less than 2 and greater than -2 at the same time. So this is what our and graphs will look like. Now there'll be a time later on when they're not always going to look perfect like this. They change around, but we're not going to deal with those. All right, so number 19 is an or compound inequality. We solve those just as two separate equations, and we put them both on the number line. Now, or doesn't have to be in the same place at the same time. It can be one or the other. That's 6x minus 5 greater than or equal to 7. So we're going to solve this equation separately. We're going to subtract 5. I have 2x is less than or equal to -8. And I'm going to divide by a +2. Okay, a lot of kids make mistakes here because they think, oh, there's a negative over there, I should flip the sign. But this is not the case. X is still less than or equal to -4 because the number that I divided by here is a +2. And the other one, so add 5. I get 6x greater than or equal to 12. Divide by 6. X is greater than or equal to 2. And it's important to bring down the word between. Or is an important part of this. We have numbers that are greater than or equal to 2. So that's a closed circle at 2. Greater than. That's 3, 4, 5, 6. And then -4, we have numbers that are less than or equal to 4. And that's -5, -6, -7. And so our shading should go opposite directions with the or. For now, sometimes it switches and we end up with like all real numbers or something like that. But for now, it's going to be pretty basic. Number 20. X plus 4 is greater than 0, or 32 less than or equal to -4x. I don't know why it does this to me. That's a -4x. I know, it's really bad writing. We're going to subtract 4. X is greater than -4. Or divide by -4. Dividing by a negative, so -8 is greater than or equal to, the sign flips, x. And I'm going to flip it again. X is less than or equal to -8. And when I look at it on a number line, -8 is smaller. -4 is larger. I want numbers less than -8 and greater than 4. I'm going to have a closed circle on the less than or equal to and an open circle at the 4. All right, I'm going to delete this stuff up because we got a lot more to talk about when we get to these compound or these absolute value inequalities. Okay, so let's remember that the absolute value of x is the distance a number is from 0. So if we have the absolute value of x equals 3, that's x is equal to 3, but it's also equal to negative 3 because both of those numbers are 3 away from 0. When we're looking at an inequality, we want absolute value of x being more than 3 away from 0, and it helps to look at this on a number line. If I want more than 3 away from 0, I want numbers that are greater than 3 or numbers that are less than negative 3. And the open and closed circle just depends on the problem. These would be open. So greater than is an OR inequality. And when we write that, this inequality is x is less than negative 3 or x is greater than positive 3. So our inequality symbols are opposites. That's different from our ands. When we look at an and inequality, we have the absolute value of x is less than 3. I want numbers that are less than 3 away from 0. Open circles, and that's the numbers that are between 3 and negative 3. We write this negative 3, oops, that doesn't work very well. Negative 3 less than x less than 3. Signs are the same, right? Both less thans in this between notation. So less than is an and we prefer the between statements. So, in number 21, we have the absolute value of x minus 2 is less than 1. Less than is an and. So that's going to be between negative 1 and positive 1. What is between there? The x minus 2. And then we treat it like a regular compound inequality, add 2 to both sides. So 1 is less than x, which is less than 3. And I can draw that on a number line, open circles, and a shaded between. And then number 22, the absolute value of 2x minus 5 is less than or equal to 5. So that's less than is an and. It's going to be between negative 5 and 5. And it's the 2x minus 5. That's in between there. So we're going to add 5 to both sides. Didn't mean to change that. But anyways, we get, that's a negative. So 0 less than or equal to 2x less than or equal to 10. Move it up a little. And then we can divide by 2. So 0 is less than x is less than 5. And we can shade between 0 and 5. Well, I totally just did all these problems and wasn't recording, so we're going to do them again. The absolute value of x plus 3 is greater than or equal to 1. So this is x plus 3 is greater than or equal to 1, or x plus 3 is less than or equal to negative 1. So we'll subtract 3. I sometimes just do it to all of the equations because it's the same on the inequalities. And I get x is less than or equal to negative 1 minus 3 is negative 4. Or x is greater than or equal to negative 2. I can draw that on the number line, close circles, less than, negative 2, close circle, greater than. Now here we have a special case in number 24. Number 24, when is the absolute value that's always positive greater than or equal to a negative? And the answer is always. So because that's always true, our answer is all real numbers, which is this double-lined R. You can write it out if you want. And the opposite is true if I had the absolute value of 2x plus 7 is less than or equal to negative 7. When is a positive less than or equal to a negative? That answer is never. And so there's no solution on that one. Number 25, negative 3, absolute value of negative 3 minus 2x, absolute value minus 5, greater than or equal to negative 14. We have to get this absolute value by itself first. So to do that, I'm going to add 5. Add 5. And we can't determine whether it's no real solution, all real numbers, or no solution until the absolute value is by itself. So negative 3, absolute value negative 3 minus 2x greater than or equal to negative 9. Divide by negative 3. And the absolute value of negative 3 minus 2x is greater than or equal to positive 3. No, not greater than or equal to. I divided by a negative, so my sign has to flip to the less than or equal to. And now I can write negative 3 less than or equal to negative 3 minus 2x less than or equal to 3, because we want numbers that are less than 3 away from 0, and those would be numbers between 3 and negative 3. And then we're going to solve this. We're going to add 3 to this side, add 3 to the right, add 3 to the left, 0 less than or equal to negative 2x less than or equal to 6, divide by negative 2, and my sign has to change again. And so this makes it kind of weird. Negative 0 greater than or equal to x greater than or equal to negative 3. So I have to flip it around, and my signs have to stay oriented the same way. Negative 3 less than or equal to x less than or equal to 0. And then that's numbers that are between negative 3 and 0, closed circles, and shaded between them. All right, I know this is a long video, but we are almost to the end. Okay, again, we're going to get the absolute value by itself. Okay, so this has to be by itself. To do that, we're going to subtract 7. So I have the absolute value of 2x plus 4 greater than or equal to 6. Sometimes I make my absolute value bars really tall so it doesn't look like a 12 or something. Greater than is an or, so 2x plus 4 has to be greater than or equal to 6, or 2x plus 4 is going to be less than or equal to negative 6. It changes sign because those are where the numbers are more than 6 away from 0. And we're going to subtract 4. So we get 2x greater than or equal to 2. We're going to divide by 2. So x is greater than or equal to 1. We're going to subtract 4. So we have 2x is less than or equal to negative 10. Divide by 2. X is less than or equal to negative 5. I didn't divide by a negative. I divided by a positive. So the sign stays the same. Greater than or equal to 1. That's that way. Close circle. Less than or equal to 5. And that's our final answer on that one. Number 27. 2 absolute value of 10 minus x greater than or equal to 6. Again, getting the absolute value by itself, I'm going to divide by 2. 10 minus x greater than or equal to 3. Greater than, 10 minus x is greater than or equal to 3, or 10 minus x is less than or equal to negative 3. And then subtract your 10. So we have, let's move this stuff up. Negative x less than or equal to negative 13. Divide by negative 1. X is greater than or equal to positive 13. Or minus the 10. Negative x less than or greater than or equal to negative 7. Divide by negative 1. X is less than or equal to positive 7. So here our answer is between, or is, let's see, less than 7 with a closed circle, and greater than 13 with a closed circle. And then one of our last problems here, I'm going to move it over so I can see it all. 3 times the absolute value of 2x minus 4 plus 4, 4 greater than or equal to 16. Get the absolute value by itself by subtracting the 4. 3 times the absolute value of 2x minus 4 is greater than or equal to 12. Got to get the absolute value by itself first. So absolute value of 2x minus 4 is greater than or equal to 4. Now I can write my two equations. 2x minus 4 is greater than or equal to 4. Or 2, oh wait, what happened? 2x minus 4 less than or equal to negative 4. And we'll add 4. 2x is less than or equal to 0. Divide by 2. X is less than or equal to 0. Add 4. 2x is greater than or equal to 8. Divided by 2. X is greater than or equal to 4. And that makes our number line 0 and 4. Closed circle, less than 0. Closed circle, greater than 4. And lastly, our 3. Okay, here are our last 3 problems. A number is no less than. If it's not less than, that means it's greater than or equal to. So x, pay attention to the variable it gives you. Okay, you want to use the variable it gives you. It's not like I'm going to mark you off, but you should be paying that attention, especially like on a multiple choice test that you could lose points for. So x is no less than, no less is greater than or equal to negative 8. A number y plus, that's add, 2.4 is less than or equal to, that's less than or equal to 35. That one's pretty straightforward. And then a number b divided by negative 3 is greater than or equal to 6. And that's a wrap.